So now what we're going to do is we're going to take some of the problems that we just talked about in terms of looking at the standard normal distribution and take them just kind of a step further. Most of the things in the real world don't have a mean of 0 and a standard deviation of 1, like the examples that we were seeing when we were talking about the standard normal distribution. What we're going to do in this section is we're going to take what we used in the last few sections and figure out a way to convert a problem that doesn't have a mean of 0 and doesn't have a standard deviation of 1 into something that really has a mean of 0 and a standard deviation of 1. And the trick that we're going to use is we're going to convert everything into an equivalent question, but asking it about z-scores. Because if we convert these things to z-scores, the z-scores have a mean of 0 and a standard deviation of 1. Let's go through this example. IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. Let's look at this question here of what you get, what is the probability of randomly selecting one person who has an IQ score that is greater than, say, 133. Now, what we want to do is convert this into an equivalent question that asks about z-scores, or asks the same thing, but about z-scores. And the way that we do that is we use the values here and we convert them to z-scores. For example, what is the z-score that corresponds to an IQ score of 133? Well, the formula that we have for z-scores is that the z-score is x minus mu over sigma. So we're going to convert this into a question about z-scores by plugging in this 133 and figuring out what's the probability of getting a z-score that is bigger than whatever the z-score is for 133. Let's calculate that now. The z-score for 133 would be 133 minus the mean, which is 100, divided by the standard deviation, which we said was 15. And if you plug this in, you'll see that that is 2.20. If we keep our rounding rule of rounding to 2 places for z-scores. So, really, the equivalent question is, what is the probability that the z-score for a given person is greater than 2.20? Now we've converted it into a problem with the standard normal distribution. These are z-scores. The mean is 0, the standard deviation is 1, and we're interested in what is the probability that z is greater than 2.20. So we're looking for this area up here under the curve, but to the right of 2.20. And we said in a previous video that the way we would do that is to use normal CDF, parentheses, and we describe this interval again. And the interval starts at 2.20, and it ends at infinity. And we'll use 9999 for that. And we can plug that into our calculator. And we get 2.20, comma 9999 after we typed in the normal CDF. We get that the value is 0.0139, or about a 1.39% chance of getting a z-score that's greater than 2.20, which is the same as saying, what's the probability of getting a particular IQ score that's bigger than 133? There's only about a 1% chance of selecting a person randomly with an IQ score of 133 or higher.